And what we need to cover today out of 1-4 is we need to cover zero factor, and we also need to talk about the quadratic formula. So last time we talked about the square root property and how to use it to solve equations. Today we're going to learn zero factor and also how to use the quadratic formula. So those are our 2 parts left out of 1-4. And so we're going to begin today with zero factor. So we're going to use what's called the zero factor property to solve some of these quadratics. And to use a zero factor, it's got the name implies what it is. For zero factor, step number 1 is you set the equation to 0. Step number 2 is you factor. And step number 3 is you set each factor to 0 and solve. So this is going to be zero factor here. So what we do is we set it to 0. We factor it. These are going to be trinomials. We're going to factor them. And we're going to set each factor equal to 0 and solve it. Now on these, we're going to get up to 2 solutions. You may have 2 solutions, or you may just have one that's a double root. So you either have 2, or you'll have one of them that's the same, that's repeated twice. The first ones that we're going to look at using zero factor are the easier ones. We don't have to use factor by grouping on these. Now the later ones we will, but I'm going to pick these from our textbook. And these are on page 139. And we're going to begin with a very simple one. We'll start with question 13. We're going to be applying the zero factor. So x squared minus 5x plus 6 equals 0. So let's first talk about why we can't just solve it like we did in 1-1. Well, this is nonlinear. Remember, we talked about the difference between linear equations and nonlinear equations. This is nonlinear because of the square, right? The x squared there makes this now nonlinear. And in nonlinear, we have to come up with different techniques of solving it. And so we're going to learn today zero factor. Last time, we learned the square root property. Today, we're going to learn zero factor. And every instructor teaches zero factor a little bit differently. I teach it using factor by grouping. Some instructors have you guess the factors. I like factor by grouping. Now, what I'm going to do is if there's no number in front, I'm going to put a 1 out front. And then you will always take the first number and you multiply it by the last number. So the first number times the last number. And then we're going to put it in a box. So 1 times 6, that makes it a 6. Okay, so you always take the first times the last. Now, what we want is we want 2 numbers to multiply together to give you 6. In this case, add together to give you a negative 5 in the middle. Do what now? Yep. That's what we're getting to. It'll be 3 and 2, right? Now, yep. You had it already. You jumped ahead of me there. That's okay, though. Why are they both going to be negative? Well, we've got the 6, and what do we know about the 6? 6 is positive. Now, how can we multiply together to make it positive? There are either 2 positive numbers, right, or 2 negative numbers. In this case, what's a sign in the middle? Negative, right? Sign in the middle is negative here. This 6 is positive. That means they're either both positive or both are negative. Now, in this case, we know the middle's negative. And you said it correctly. We need a negative 3 and a negative 2, right? Because when you go to check, negative 3 times negative 2, that's positive 6. And minus 3 minus 2 matches with that negative 5 in the middle. Now, on these, when there's a 1 out in front, you can jump directly to your factors. And so this factors directly down into x minus 3, x minus 2. So we factored it. Now we need to finish it. Your answers are not going to be minus 3 and minus 2. Those signs are wrong. We need to make sure we actually set it to 0 and get the correct sign. So what are they going to be? X minus 3 equals 0. I always write it out so you remember to move it over and change your sign. So that's going to now leave you with one solution, which is minus 3. Make sure you're careful with the signs. Oh, sorry, positive 3. Yep, my mistake there. I wrote it wrong. It should be positive 3. And what about the other one? X minus 2 equals 0. We're going to add our 2. Okay, and that gives you positive 2. So our solutions are positive 3 and positive 2. Question 14 is similar, but the signs are different. So let's look at 14, and then we'll look at some more complicated ones. So question 14 is x squared plus 2x minus 8 equals 0. So is there a number in front of the x squared? No, we put a 1 there. And then 1 times negative 8. 1 times negative 8 is a negative 8. That is negative, right? How can we get two numbers to multiply together to give you a negative number? Well, the only way you can get two numbers to multiply to give you negative is one has to be positive, one has to be what? Negative, right? Now, what's the sign in the middle? So that positive is going to be the larger number, and I always write it first. So we need two numbers multiplied together, in this case to give you 8. Subtract, because they're different signs, subtract from each other to give you a 2. And why are they going to, one be positive, one negative? Because that's negative. So since that's negative, let me write that down. 1 is going to be positive, one number's negative. Sign in the middle is the larger one. So that goes with the larger number, and I always write it first. Now, what two numbers multiply together to give you 8, subtract from each other to give you 2? 4 and 2, right? Now, we know 4 is our larger number, and we write it first, and that matches with our sign here. See, as long as you're careful with the pattern, that matches, and our smaller number is a 2. Now we can rewrite this into our factors. And what does that factor into? That factors into x plus 4, x minus 2 equals 0, right? And then x plus 4 equals 0. So x equals now a negative 4. And x minus 2 equals 0. So x equals 2. Those are our two solutions. So let's talk quickly about what we did and how we factored this out. We took the first times the last. We put that number over here in the box. Now, if it's positive, they're the same signs, like the previous one. This one, it's negative, so that means one is positive, one is negative. Then we go to our sign in the middle. Sign in the middle is positive in this case, so larger numbers positive, smaller numbers negative. We can then jump directly to our factors, and we set them equal to 0, and we solved it. Now I'm going to make up another one for us to work through. How about we look at, I'll make one up here. How about we try to solve this one? This way we'll have one we got to factor things out of. How about 9x squared? How about a minus 3? Let's do it something in the middle here. I'll just make up one real quick here. How about we put a positive 28x in the middle? So this one will factor. Now, this one is a little bit different because of the 9 in front. So first thing we need to always do with these, we're using zero factor. So we need to make sure it's set to 0. So the first thing that we do is we're going to move that 3 over. So we're going to add 3 to both sides. So we now have 9x squared. We've got a plus 28x, and a plus 3 equals 0. Now this one does require an extra step or two, because on this one, we're going to have to factor by what's called grouping. So we do the same method, we just have one extra step. So first times the last. 9 times 3 is a 27. And I try to make this one easy to factor as well. What do we know about the signs? Are they different or are they the same? Same. Why the same? Because it's positive. So since it's positive, in this case, both are going to be what? Positive. Why are they both positive? Because that's your larger number. Okay, in this case, they're both positive. They could be both negative. If this was a negative here, they would both be negative, right? But this one's positive. So since this is positive, they're both the same. In this case, sign in the middle is positive. So that means they're both positive. What are they going to be? Can someone tell me? Multiply together to give you 27. Add together to give you 28.
91 or 1?
Well, we need two numbers that multiply together to give you 27, right? Add together to give you 28. How close is 28 to 27? It's off by what? 1. So how about we try 27 and 1? Is that going to work? Yes. Because how do we know? How do we check it? Okay, we check it because 27 times 1 is 27. And 27 plus 1 is 28, which matches in the middle. Now, we cannot just jump to our factors. We have to do one extra step. And now we have to do what's called factor by grouping. So we're going to take the ends and keep them the same. So the 9x squared and the 3, well, they stay the same. Now, we're going to take this middle, this 28x, and we're going to split it up into our two factors. If this was a 1, you could jump to your answer, just like we did previously. But if it is any number besides a 1, you've got to factor by grouping. So this was a 9, so we split it up. Now the 28 will split up into 27x and an x. Now once we have split this up into our 4 pieces, we are going to factor by grouping. And so we group the first 2 together, and we take out what's in common. And this is just one method of factoring. There's other ways of factoring. I don't care how you factor, as long as you get the correct answers. So let's look at what I've got underlined here. What can I factor out of the first 2 pieces? Well, larger than a 3 I can factor out. You always have to take out the largest number. Is a 9 in common with both of these? Yes. So we're going to take out a 9, and we're also going to take out an x. And that leaves you now with an x plus 3. The next 2 pieces, does that x and that 3, do they have anything in common? No. So we can always factor out a 1, and that leaves you now with an x plus 3. Okay, so if nothing comes out, remember, you can always factor out a 1. Now, we know we are doing it correctly because these groupings had better be the same. If the groupings are different, you made a mistake. Are the groupings the same here? Yes, they're both x plus 3, aren't they? Okay, so these are the same. And this is still equal to 0. And now we can rewrite that as x plus 3 out in front. And what's left over? 9x plus 1. That now equals 0, doesn't it? And we can now finish it. So what are my solutions going to be? Well, we've got x plus 3 equals 0. We move that 3 over. So one solution is a negative 3. Let's get it by moving it over. What about the other one? Okay, 9x plus 1 equals 0. Move that 1 over. So that makes it 9x equals a negative 1. We divide by our 9. And what's our second solution? Negative 1. And it's very important that we know how to factor. And so we're going to do some more of these as well. So this is just the very beginning of these. We're going to factor a lot. We factor in the rest of this chapter. We also factor in chapter 2 as well, and some of the later chapters also. But factoring is very, very important. So let's do another one. And let's use a 16 here. Okay. And let me come up with the factors that are going to make it work. How about we use a negative 62. Make sure that'll work real quick because I'm just making these up as we go along. Yep, negative 62x. Okay. And I made this one up on purpose so you can see how to reduce it down at the beginning. So, zero factor, again, is how we're going to solve it. So we're going to solve with zero factor. So, zero factor, it says in the name what to do. You set it to 0, and you factor. So move that 16 over. Now, look at the numbers. If I was to take the first number and the last number, that would be 8 times 16. Which is pretty large. We can reduce these numbers if we see a number in common. So let's look and see what we've got here. We've got an 8, we've got a 62, and we've got a 16. What number's in common? Well, they're all even, so I think a 2's in common, but is a 4 in common? No, 4 is not, but all of these have a what number in common? All of these are divisible by 2. So we're going to divide everything now by a 2. And that's going to make our numbers a lot smaller and easier to handle. So now when I divide by that 2, okay, everything gets divided by the 2, including that 0, but 0 absorbs it. 8 divided by 2 is a 4x squared. 62 divided by that 2, yep, that makes it a minus 31x. And 16 divided by 2, that makes it a minus 8. And that equals now 0, doesn't it? Okay. Pretty simple on this one again. First times the last. First times the last, watch your signs. First times the last, that's a negative. In this case, negative 32. And it's negative, so what do I know? Positive, 1 what? Negative. So is everyone okay with what we did so far? So we set it to 0. All right, and then always before you start working with the box, make sure that nothing factors out. So look at all the numbers together and see what number, if any, will come out. The numbers will be a lot easier to deal with in factor if you divide by that 2, like in this one, early. Now, sometimes that may not be possible, but if it is, you want to do that. Now, first times the last is a negative 32. It is negative, so that tells you one has to be positive, one has to be negative, and what's the sign in the middle? Negative, so the larger one is negative, smaller one is positive. And look at the middle and compare it to the box. These are off by what? 1. So how about we use a 32 and a 1? So a negative 32 and a positive 1. That'll work, won't it? The numbers are usually small and easy to work with. You're not going to have any really terrible numbers. So they're going to be small and easy to factor. Now, we can't just jump to our factors. We have to split this up. So we split that middle up. The ends stay the same at 4x squared and a minus 8. And we split that minus 31x into a minus 32x and a positive x. Now we factor again. First two pieces. What can come out of the first two pieces here? Always take out the largest number in common, and these both have a what in common? Yep, 4 and an x, so we took that out, and that leaves you with an x, in this case, minus 8. And the next two pieces, there may or may not be something in common. If there's nothing in common, you can always take out a 1, so we're going to take that 1 out. And that's going to now leave you with an x minus 8. How do we know we're doing it correctly? Well, those parentheses had better match up. If they are different, if this would have been a minus 8 and this one was a minus 2, you made a mistake. So always check those parentheses. They better be the same. If they are the same, then these can come out in front. So an x minus 8 comes out. And what's left over? 4x plus 1. Now we can finish it. So x minus 8 equals 0, so x equals 8. And 4x plus 1 equals 0. So 4x equals negative 1. And so x now equals a negative 1/4. Try another couple of these questions. I want to pick out 17 from the textbook because it's going to make you divide by a negative at the beginning. So let's look at question 17 in your textbook. If you don't have your textbook, that's fine, because I'll just write it up here for you. It's going to be on page 139. We're going to look here at question 17. This back up again. So we're going to look at question 17. And this one is going to make you divide by a negative at the end before you factor. And again, same directions, solve with 0 factor. So we're going to try and solve this with 0 factor. So step number 1 is we have to set this to 0. So I'm going to add this 3 over. Now we've got a minus 4x squared. We have a positive x and a positive 3. One habit you want to get into is never work with the x squared when it's negative. you're really going to make sure it needs to be positive when you use the quadratic formula. So we're going to make sure it's positive also for the 0 factor. So if it begins with a negative, we need to get rid of that. And how we do that is we divide everything by -1. So everything is going to get divided by -1. That way your x squared stays positive or starts off positive. And that's just the easiest way to work with these. If it's negative, it just adds in an extra step and is more confusing. So make sure it stays positive at the beginning. So divide by that -1 there to make it positive. So whatever you got, just divide. Now, look at the numbers. 4 and 3, do they have anything in common? No. So nothing can be divided out. First times the last. Okay, first times the last. -12. It's a -12. What do we know about the signs? Are they the same or are they different? Okay, they're different. And which one's larger? Negative. So one is positive. One is negative. Larger one being negative. Smaller one is positive. Very, very easy to factor. What two numbers? 4 and what? 4 and 3, right? And we need a -4, +3. Can we jump to our factors? No. Why not? Because of the 4 here. If it's anything besides a number, or besides a 1 out in front, you've got to factor. So if you have any number besides 1 in front, you've got to factor it by grouping. If it's no number, if there's just a 1 that you added in, you can jump to your factors. But any other number, do it by grouping. So now that leaves you with 4x squared. And then we've got a -3 on the end. And then the minus x splits up into a -4x and a +3. Factor by grouping. And first two pieces, what can come out of here? Yep, it looks like these can factor with a 4 and an x, right? And that's going to leave you with an x -1. Next two pieces, what number's in common here? 3, and I think I forgot the x there. Sorry about that. Should be an x there because you split that up. Okay, so these have a 3 in common, so that 3 comes out, and that leaves you with an x -1. Are my groupings the same? Yes, they better be the same, else you made a mistake, or it's not factorable. So these are the same, so that comes out as an x -1, and what's left over? 4x +3. What are our answers going to be? X -1 equals 0, so x equals now 1. And 4x +3 equals 0, so 4x equals a -3. We divide by our 4, and so x now equals a -3/4. So is everyone okay with how we did that? That makes sense? All right. Let's look at one more. Let's look at question, how about question 21? And then we'll look at the quadratic formula. Let's look at question 21 here. Now, normally we get two different numbers. But in some cases, you might get one number, but it's repeated twice. And that can happen. This is what's called a perfect square trinomial. And you can factor it as a perfect square, or you can just take the first number times the last number like we've been doing. So this is a perfect square trinomial because 4 is a square, 1 is a square. But let's go ahead and factor it just like we've been factoring them before. First times the last. 4 times 1 is a 4. What do we know about the numbers? Are they different signs or are they the same? 4 is your positive here, right? So that means they're both the same. And what's the sign in the middle? Negative. Okay. So we need them to both be negative. Multiply together to give you 4. And also add together to give you 4. The only one that's going to work with is going to be what? Multiply together to give you 4. Also add together to give you 4. What two numbers would work? That won't work. How about 2 and 2? Does 2 and 2 work? Because 2 times 2 is what? 4, right? And 2 plus 2 is also what? 4. So you have to make sure they multiply together to give you the number in the box, add or subtract to give you the middle. And in this case, they're going to give us the same result, same answer. So we're only going to get one solution. Now we work it through the exact same way we did the last one. So we've got 4x squared into 1. And that breaks down into now 2x and minus 2x are so both negative. We split that up. We're going to proceed the exact same way as previously done. 4 and 2, what number do they have in common? They have a, what am I going to factor out of here? 2 and an x, right? And that leaves you now with, well, 4 divided by 2 is a 2x. Minus 1. Okay, the next two pieces, I need it to be the same. This looks like that, except the signs are what? Signs are different. So how can I fix that sign problem? I can factor out a negative 1. And if I factor out a negative 1, that's going to change them. And that makes it a 2x minus 1. And now our groupings are the same, aren't they? They have to be the same. Whenever you factor in a negative, that switches both of your signs. So I factored the negative 1 out so it would switch them, so it would match up with that one. Now these are the same. So that's 2x minus 1, gone, gone, and also 2x minus 1. What do you notice about these? These are the what? The same, right? So how many solutions am I going to get? Just one of them because of the same. So now we just simply solve 2x minus 1 equals 0, 2x equals 1, and x equals what? 1 half at the end. You could have also saw that this is a perfect square trinomial because 4 is a perfect square of 2. 1's a perfect square of 1, and you could have actually jumped straight to the answers. But that's okay if you didn't see that. Take the first times the last, find the two numbers. That's zero factor. We're now going to look at the last part of this section, which is the quadratic formula. So we're still in 1-4, we're going to learn about the quadratic formula. So we're now going to be learning about the quadratic formula and how it works. To use the quadratic formula, it has to be set up in a specific way. If we want to use the quadratic formula, it must look like this. So to use the quadratic formula, it must look like ax squared. write it right here. Sorry about that. Put the square in the right place. So ax squared plus bx plus c equals 0. It has to look like that. Right? So what we want to do is we want to make sure that it looks like that. And then we can apply our quadratic formula, which is x equals minus b plus or minus the square root of b squared minus 4, ac, over 2a, right? Okay. You probably heard of that before, but this is our quadratic formula. We use the quadratic formula when zero factor doesn't work, because in many cases you may have a trinomial. Trinomial means it has 3 terms. You may have a trinomial that you can't factor, either because it has non-real solutions or irrational solutions, but it won't factor. So how we approach those type of problems is we use what's called the quadratic formula. Students are okay with the quadratic formula, but it's easy to make a mistake with the signs. Again, it all goes back to the signs. When I looked at your homework, it's the same thing. Most of you know how to do these questions. You might accidentally lose a sign or maybe multiply or divide incorrectly. It's the small things. So when we do use the quadratic formula, we need to make sure we take our time. Never rush through it. You'll end up spending more time than if you would have just took the correct time the first time. So we're going to go ahead and now solve these with the quadratic formula. So solve these with the quadratic formula. And we'll start with this one. How about 4x squared minus 5x equals minus 4. Now, it really doesn't matter whether we're going to use zero factor or whether we use the quadratic formula. First thing we do in either method is we make sure that it equals 0. So no matter which method we're going to use, zero factor or the quadratic, it has to be equaling 0. So the first thing we're going to do is we're going to add this 4 over. And make sure that it equals 0. Once that 4 has been moved over, then we look and we make sure that we cannot factor anything out. 4 and a 5 have nothing in common, so we can't factor anything out. We make sure it stays positive at the beginning. Our 4x squared is positive, so that's okay as well. Now we need to label our pieces, right? And look at our formula. It needs to look like this: ax squared, bx, and c. So we need to label our a, our b, and our c. A is a 4. B, watch your signs here, is going to be a negative 5. And C is 4. So make sure you're very careful with those signs. Make sure it's in the correct order and that it is set to 0. The quadratic formula is really not difficult to work with, but students make mistakes in the signs or multiply incorrectly. So we really want to make sure we take our time. What I always like to do is I like to write up our formula again each time. So x equals minus b plus or minus the square root of b squared minus 4ac over 2a. And now I'm going to plug my numbers in. When you plug your numbers in, make sure you're very careful about double negatives, especially with that b. So we're going to plug in a negative b. So we have a negative of a negative 5. So I use parentheses, right? It's a negative 5, and it's negative in front. So that's going to be a double negative. We'll deal with that in a moment. plus or minus. Then we have b squared, so that's a minus 5 squared. Then we have a minus 4, a, which is 4, c, which is 4 as well. And that's all going to be over 2 times a, which is 2 times the 4 there. Is everyone all right with what we've got so far? And take your time with these. Don't rush through them. Now, I like to do everything in small pieces so we're less likely to make a mistake. So what I'm going to do is I'm going to go ahead and work with the signs. So we know the double negative here. That double negative makes that a positive 5. Then we've got our plus or minus. We've got our square root. We're just going to leave the square root there. In the denominator, what do we have? 2 times 4, that's an 8. On the left-hand side, I am going to work with our discriminant. And our discriminant is everything that's underneath that square root. So our discriminant by definition is what is under the root. And what is underneath our root here? So discriminant is always what's underneath your root. And that's going to be a minus 5 squared. Minus 4 times 4 times, in this case, 4. Lots of 4s there. Be careful with your signs. Here's where students might make a mistake. When we square that negative 5, what does it become? It becomes a positive 25, right? Because negative 5 squared, when we square a negative number, it becomes positive. So that's a 25 there. Now we have one negative here, so my sign's going to be negative. We take those 4s and we multiply them together. So that's 4 times 4 times 4, which is then 64. And now we take our 25, subtract off that 64, and that gives you a negative 39. In some cases, you may be able to break it down. In some cases, it may not. Okay, 39 doesn't really break down any because 39 breaks down into what? 39 breaks into 3 and 13, but that's not going to go any further, is it? So we can stop there. Now, what we do need to do, since this is a non-real number, is we need to rewrite it as 5 plus or minus, I'm going to bring that I out, square root of 39 over what? Over 8. And you can leave it like that, and that's the way the textbook sometimes writes it, or you can split it up into 5 over 8 plus or minus the square root of 39 over 8i. Okay, either one is going to be the same, and either one is fine for your answer. So I'll take either one. They're the same. I made these questions multiple choice. That way it's easier to see if you're working them out correctly or not. Because when you work these out, your answer should match up. If it doesn't to one of the choices, you know you made a mistake. That's why I made those multiple choice. Just so you can see if your answers even look close or not to what they should be. Okay, let's try another one. So this is what we've got here. And again, we're going to solve it. We're going to be solving all of these using that quadratic formula. So what's our first step going to be? Just like it's 0 factor, we set it equal to what? 0. So let's go ahead and do that. Add 10x and add 12. And that gives us now a negative 8x squared, a positive 10x, and a positive 12. Well, what do we need to do? We need to see if we can reduce this down first, right? Because watch your signs, I moved everything over, didn't I? Okay. Now, can we ever begin with a negative x squared? No, we don't want to do that. And we also look at our numbers. We have an 8, a 10, and a 2. So what's in common? What can I divide out? Looks, yep, 2. And there, we don't want it to be positive, so we're going to make it a negative, or sorry, we don't want it to be negative, so we're going to make it positive. So we divide it all by a negative 2. And now we're going to rewrite. The numbers will be smaller and much easier to work with. So now we can rewrite this as 4x squared. Watch your signs. We've got a minus 5x. And we have a negative 6. And that equals now 0. Okay. Is everyone all right with that so far? Yep. So just take your time. Again, don't rush through these because that's where you'll make your mistakes. Sign errors are where you make the mistake. Yeah, you could have also just have moved this negative 8x squared over to here, and it would have been the same thing, right? And then divide by the 2. I always move everything to the left, but you can move it to the right to save a step. Okay, same thing. But eventually, either way, you're going to end up with that. Now, what is our A going to be? What's the A going to be? The A is going to be 4. The B we need to be careful with. Yep, minus 5. Careful with your signs there. And C is a negative 6. Now we can write up and apply our quadratic formula. So that's negative B plus or minus the square root of B squared minus 4AC all over 2A. And now we're going to apply that with our numbers. Watch out for double negatives, so be careful with those if you have one. We have a minus 5, plus or minus. We've got the square root of minus 5 squared, minus 4, times A, which is 4, times C, which is a negative 6. And that's all going to be divided now by 2 times 4. Take your time. Now again, I like to break this up into smaller pieces. So the first thing I do is I'm just going to rewrite this. Double negative here makes that positive 5. And then we've got plus or minus. We've got our square root, which we'll do on the left. And the 2 times the 4, that makes that an 8. Now we work with our discriminant. That's minus 5 squared, minus 4, times 4, times a negative 6. Now the last one, it came out to be a non-real number. This one's going to be real. So this one's not going to be imaginary. This will be a real number. Negative 5 squared is positive 25. What about here? Watch your signs. A negative and a negative now makes that a positive. So what I do is I find my signs first, because negative and negative makes it positive. And now I just simply multiply them all together. So 4 times 4 times that's 6. That makes that a 96. It's positive, right? Because 2 negatives make it positive. Add that 25 to it, and we get 121. Always check first before you try to break it up to see if it's a perfect square. You don't want to have to go through all the work of trying to split it up just to realize it was a perfect square at the beginning. 121, okay, is a perfect square of what? We use our square root key. 121 is a perfect square of 11, right? So in this case, it's going to break down into 5 plus or minus 11 over 8. And now since it's a perfect square of 11, we need to actually get our two numbers because the square root went away. So we need to get our two solutions now because they're rational numbers. And what do we have? We have 5 plus 11 over 8 is one solution. And the other one is 5 minus 11 over 8. And whenever that square root's gone, you need to get the two actual real solutions. And 5 plus 11, well, that's 16 over 8. And that reduces down to be what? 2. So there is one solution, which is 2. You could have factored this one as well, right? Or you can use the quadratic formula. You'll get the same result. What about the other one? 5 minus 11. Okay, well, 5 minus 11, that's a minus 6. And minus 6/8, we need to reduce it down. That's going to reduce down to a minus 3 what? Minus 3/4, isn't it? And there's your two solutions. Because that one came out to be a perfect square. And that sometimes will happen. Sometimes you may have to break up the root. Sometimes it's real. Sometimes it's non-real because it's negative in the discriminant. One thing you never ever want to have in the quadratic formula is fractions. So if you have fractions, you want to get rid of them. Never put fractions in the quadratic formula. So if you have them, you've got to get rid of them from the beginning. So we're going to solve again with the quadratic formula. So I'm going to give you this equation to solve here. And you can either move the 9 over now, or you can just get rid of the fractions. It doesn't matter. It's going to be the same either way. A lot of times students like to just get rid of the fractions in the very beginning. So if I want to get rid of the fractions, what do I need to multiply all of this by? Not 2. 8, right? Because the least common denominator of 8 and 4 is a 8. So everything now gets multiplied by 8. So when we clear these fractions, how does it work? We divide by the number down below, the denominator, multiply by the numerator. So divide, multiply. So 8 divided by 8, well, that is a 1 times 3, that makes it a 3x squared. Negative is on the next piece. 8 divided by 4, well, 8 divided by 4 is a 2, times that negative makes it a minus 2x. 8 times 1 is an 8, and don't forget the other side. 8 times negative 9, well, that's a negative 72. Right, you have to move it. Do it to all of it. You could have moved the 9 over first. It wouldn't matter. If you wanted to add 9 first, same result. You're going to get the same answer. I chose to just clear the fractions. Now we need to set this to 0, so we're going to add that 72 over. And now we have 3x squared. We have a minus 2x, a plus 80, and that equals 0. Is it in the correct order? Yes, it is. We can now apply our quadratic formula, and we find our A, our B, and our C. And in this case, A is a 3, B is a negative 2, and C is 8. Try and get this to be straight here. Okay, so there we go. We've got our A, which is 3, B, which is negative 2, and C, which is 80. Right, not 8, should be 80 there. Okay, so what do we apply? Apply our quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then we plug our values in. Negative of a negative 2 plus or minus square root. We've got our b squared, so that's minus 2 squared minus 4 times a, which is 3, times c, which is 80, all over 2 times 3a. So again, you want to make sure you take your time. This one we're going to end up reducing it down at the end, I believe. So we'll see how the root works, but I believe this root will be reducible. So let's work with our discriminant, and our discriminant is what's underneath the root. So we'll work with our discriminant separately. So that's minus 2 squared minus 4 times 3 times 80. Negative 2 squared, whenever you square a negative, it becomes a positive number. So that takes care of that. Then you've got 1 negative, so that stays negative, right? 1 negative here makes it negative. And you've got 4 times 3, which is 12. And 12 times the 80, well, that comes out to be 960. And it's negative. So 4 minus that 960, well, that's a minus 956, isn't it? Let's rewrite this over here. The double negative here, of course, makes that positive 2. Then we've got a plus or minus. We'll fill that root in just a moment. 2 times 3 is the 6. And we found that root to be a minus 956. And always check, is 956 a perfect square? No, it is not. It's negative, right? So that means it's going to be a non-real number eventually. But let's see if we can break that down a bit. And we want to break it down into as large a perfect squares as possible. So 956, it's an even number. Let's try 2. 2 will go in there. How about we try 4 though? 4 will go. We want it as big as possible. How about a 16? 16 won't go. So 956, we'll divide that by that 4. We'll see what we're left with. So 4 and 2, 39. 239, we'll see if a 3 goes in there. It does not. 13 does not go in there. Nothing else goes in there, does it? I can't think of anything else that'll go. 3 won't go. That means 9 won't go. 7 won't go into there. So I can't break it down any further. Right? Nothing else will break into that. So now we can rewrite this as 2 plus or minus Now, what do we know about the 4? 4 breaks down into what? 2 and 2, so that 2 comes out, and I comes out with it as well. Square root of 239, and that's all over now what? All over 6. Is everyone with me so far there? So even though it was a larger number, it didn't really break down much. Why did that I come out? Because that 956 was negative. We need to break this up just like we did in 1.3. So we need to now break this into 2 separate fractions so that we can reduce. So this is going to break down into 2/6, then plus or minus 2I square root of 239 over 6. And we need to break this down and reduce it. So we had to break it up. And why did I do that? Well, 2 over 6. 2 over 6, we need to break it down. 2 over 6 is 1/3. Plus or minus, those 2's can cancel. And that's going to leave you with the square root of 239. Those cancel over 3I. So there's your solution. Or you can combine them back together. And they're the same. So you can either leave it like this, 2 separate fractions, or you could put them together as 1 plus or minus I squared root of 239 over 3. These are the same. So either one will work. They are the same. These are the same. A lot of times the textbook will write it like that. I usually split them up, but you can leave it as one fraction. Either way, they are the same. They're equivalent. Let's do a couple more of these. Let's do another one that has fractions in it. This one's actually a little bit easier to clear out. So we can solve with the quadratic formula. So we're going to try and solve this with the quadratic formula. And there is one question very, very similar to this in your homework. And it looks almost identical to question 15. Pretty much the same, different order result. Where would I begin? I need to get rid of my x squared down below. So how do I get rid of my fractions? Well, I look at my fractions as a whole, and the largest one I have down below is an x squared. So that means I've got to multiply all the components by x squared. So multiply each piece or each part by x squared. And that is going to clear out your fractions. So the x squareds, they cancel, and that leaves you with a 4x there. Let me write it in the right order here correctly. So the x squared and the x squared, those cancel. That leaves you with a 4, right? Those cancel. Then we have a minus 3. X squared cancels with one of the x, so that leaves you with a minus 3x there. And then on the right-hand side, 1 times x squared, that leaves you now with a what? X squared. So are you with me so far there? So we multiplied everything by an x squared to clear out my fractions. Now, we need to set this equal to 0, and we need to make sure that when we write it in the correct order. So I'm going to move that 4 over and add the 3x over. Doesn't matter which way you move them. And And I'm going to make sure that they're in the correct order when I rewrite this. So we've got x squared. We have a plus 3x and a minus 4. And that equals now 0. Now what I mean by the correct order is it needs to go x squared first, x, and then the number after that. And it needs to equal 0. X squared, we've got an x, and then we've got our constant, our number there. And it needs to equal 0, which it does. So now it is in the correct order. So now we can finish it. If there's no number in front of your x squared, you just put a 1 there. So a is 1, b is 3, and c is a negative 4. So watch your signs. Make sure you put it in the correct order. And now we're going to write up our quadratic formula, which again is x equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. And we plug our values in. So minus 3 plus or minus the square root of 3 squared minus 4 times 1 times a negative 4 all over 2 times 1. So we've got this. We're going to work it out. We're going to see what we've got. So that's a minus 3 plus or minus the square root. We'll deal with that in a moment. 2 times 1, that's a 2. On the left-hand side, we're going to use our discriminant or find our discriminant. And that's 3 squared minus 4 times 1 times minus 4. Be very, very careful with the signs. 3 squared is 9. A double negative makes that a positive. 4 times 4, well, that is a what? 16. Adding those together, it looks like we get 25, doesn't it? So that's what we needed. Now, again, just like one of the previous questions, 25 is a perfect square. And 25 is going to be a perfect square of what? Perfect square of 5. So I can rewrite this now as minus 3 plus or minus 5 over 2. Since the square roots are gone, let's go ahead and get our answers. And what do they look like? It looks like minus 5. Oh, sorry, let me say it correctly. Minus 3 plus 5 over 2. And minus 3 minus 5 over 2. So minus 3 plus 5 minus 3 plus 5 is a 2 over 2, which is then a what? 1. Minus 3 minus 5, that's a minus 8 over 2, which that's going to make it a minus 4. And you could have solved this with 0 factor from the very beginning. Sorry about that. But you could have solved this with 0 factor. We chose to use the quadratic formula, but you could have also have easily done 0 factor and saved yourself a lot of time. But the directions say quadratic formula, so that's what we used. We've got time for one more to look at. We've seen how to clear out the fractions. Now we're going to have to learn how to work with the parentheses. So again, solve with the quadratic formula. This one you're going to have to FOIL it out. And before I forget, I'm going to also pass out the sign-in sheet. So make sure you sign the sign-in sheet. And this will be our last question for today. So we've seen how to get rid of the fractions. When we have parentheses like this one, we're going to have to get rid of those parentheses before we can do anything else. And how we do that is we have to FOIL it. So we have to remove the parentheses so we can set it to 0. And we do that by FOILing. So we're going to have to take this and we're going to have to FOIL the left-hand side. So that's x minus 8, x minus 5. And we're going to FOIL it. So let's go ahead and take this and FOIL it. I only gave you one of these in your homework. But we're going to take this and we're going to FOIL it. So first times first, that's an x squared. Outside and outside, that's a minus 5x. Remember how to FOIL. Inside and inside, minus 8x. And last times last, watch your signs here. Last times last, negative and negative makes it a positive 40. We'll put those together in the middle, and that gives you x squared minus 13x plus 40. So what we have to do whenever we have those parentheses is we need to get rid of them. How do we get rid of them? Well, we get rid of them by FOILing. So we had to FOIL. Now we go back to our original equation. And if we want to use the quadratic formula, what do we have to do? Set it equal to what? 0, so we can apply our formula. So move that 3 over. And now we've got x squared minus 13x. Yep, plus 42. And that equals 0, doesn't it? Now we can finish it. And make sure it's in the correct order, which it is. Label your A, your B, and your C. No number in front of the x squared. You put a 1 there. So A is 1. B is a negative 13. And C is 42. What's next? Well, the next thing we need to do is apply our quadratic formula. So that is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Rewriting that. We're going to rewrite this quickly here. When we rewrite this, that gives you now negative b. So that's a negative of a negative 13 plus or minus the square root, right, of negative 13 squared minus 4 times a, which is 1, c, which is that 42, all over 2 times 1. We're going to break it up and finish it. Watch your signs. What do we know about the double negative here? Yep, so I do that first. So that negative and that negative, now make that a positive 13, plus or minus. Square root stays there. 2 times 1, that's a 2. Left-hand side, we work with our discriminant. And for our discriminant, we have a minus 13 squared minus 4 times 1 times 42. When you square that negative, 169, and it is positive. A single negative stays negative. And 4 times that 42, that's 168. And 169 minus 168, 1. And that's really simple and easy to work with because the square root of 1 is 1. So that's 13 plus or minus 1 over 2. And get your two solutions when your square root is gone. So that's 13 plus 1 over 2. And also 13 minus 1 over 2. 13 plus 1 is a 14 over 2, which is then a 7. Okay, so there's that piece. And what's our other one? 13 minus 1 is a 12 over 2, which is then a 6. So let's talk quickly about our homework. Okay, so what are we going to have due on Tuesday when we come back? Well, Tuesday when we come back, remember Monday's a holiday. So if you have Monday classes, they won't be meeting. Monday's Labor Day. We'll be here on Tuesday though, so we're going to have class on Tuesday just like normal. So what's due on Tuesday? Is going to be what? Is going to be 1.3. You should be able to do them all. And 1.4. You should be able to do them all. If you haven't done so, please turn in your homework from last time. So if you finished your homework last time, I have it graded, and you can pick it up. If you haven't turned in your homework, please make sure I get it today, and I'll get that recorded for you. But if you turned in homework last class period, I have